Hey guys, so today we're going to be talking about Polaris and how it's related to the latitude of the Earth. So let's get started. So, Polaris is one of our stars in the night sky, okay, that we can see in the night sky. And the following images are going to be showing you the perspective of an observer that is looking up at the sky from the North Pole. I want you to choose a constellation, meaning a group of stars from the diagram I'm about to show you, and track how it moves over the course of the night. So, these are constellations, meaning groups of stars with imaginary lines connecting them, and Polaris is a star that's right here. So, for an observer on the North Pole looking up at the night sky, Polaris is right here. So, notice what's happening over time. This is 7 p.m., 8 p.m., 9 p.m., 10 p.m., 11, 12 a.m., 1 a.m., 3 a.m., 4 a.m., 5 a.m., and yeah. So you might have noticed that the stars overnight are moving counterclockwise, right? But notice that even though the other stars are moving around in a counterclockwise way, Polaris is the only star that's really just staying still where it's at. And the reason is the Earth is actually spinning and it's spinning counterclockwise. So that's why, for an observer that's standing on the North Pole and looking up at the sky, the stars would look like they're spinning counterclockwise because the Earth is spinning counterclockwise, right? The stars are not actually spinning. But Polaris is actually a star that's directly above the North Pole. So if you were to draw a line from the North Pole all the way just up, directly up 90 degrees upwards, Polaris would be right there. It's called in other words, the North Star because it's directly above our North Pole. So when the Earth is spinning and a person is looking up at the night sky from the North Pole, the stars are not spinning. The stars would look like they're spinning because the Earth is spinning, and they look like they're spinning counterclockwise, right, over the night, except for Polaris because Polaris is directly above the observer. Okay. Now, what we found also interesting, actually, before I talk about that, if you were to do, say, a snapshot or fast forwarded what the sky looked like over the night, the stars would look like they were moving counterclockwise, just like this, but Polaris would stay still at the North Pole. Okay. Now, Polaris can only be seen from the northern hemisphere because Polaris is our North Star. Nobody from the southern hemisphere can actually see Polaris because Polaris would be on the other side of the world, right? It can be seen from the other side of the world. So Polaris is our North Star, and it can be only seen in the northern hemisphere. Now let's go over some vocabulary words before we move on to the next section. There are two words: zenith. Zenith means the point directly above the observer. So if you're the observer, zenith is the location directly above you, 90 degrees above you. And horizon is the point directly in front of the observer. So if you're the observer, the horizon is 0 degrees from you, meaning it's directly in front of you. Zenith directly above you, horizon directly in front of you. So why is that important? Say here's Polaris, right? This is our North Star. This is the Earth. This is the North Pole. Here's a person standing on the North Pole looking up at Polaris. For a person standing on the North Pole looking up at Polaris, they will actually see Polaris 90 degrees above them, just like this. And what we found, or scientists found, over time is that through lots of math calculations, the altitude of Polaris, or how high Polaris is actually equal to the person's latitude, meaning the latitude at which a person is located, the horizontal imaginary lines, that number is exactly equal to how high Polaris is in the sky from the person's horizon. Say a person is 45-degree latitude, right? This is the horizontal line, and here's the person. That person will also see Polaris 45 degrees from their horizon, meaning directly in front of them, the Polaris will be 45 degrees higher. Okay. If a person is at 0 degree latitude, the equator, the Polaris will also be at 0 degrees altitude, meaning the Polaris will be directly at a person's horizon, directly in front of them. If a person is at 90-degree latitude, Polaris will also be 90 degrees from the horizon, directly above the observer. So the latitude of an observer is equal to the altitude of Polaris and vice versa. So if a person is at 45-degree latitude north, they will also see Polaris 45 degrees higher or at 45-degree altitude. Notice, remember, Polaris is only visible in the northern hemisphere, so this only applies to the north, right? It can't happen in the south. So you can never say 45 degrees south equals 45-degree altitude of Polaris. It's always going to be north. Latitude in the north of an observer is going to be equal to the altitude of Polaris. Here's some other examples. If your latitude is 30-degree north, altitude of Polaris will also be 30-degree north. If your latitude is 60-degree north, altitude of Polaris will also be 60-degree north. If your latitude is 90-degree north in the North Pole, your altitude of Polaris will also be 90 degrees above you from the horizon, from directly in front of you. Okay? So let's write that down in your note packet. Latitude are imaginary horizontal lines that equal the altitude of Polaris in the north. Example, 30-degree north latitude will equal to 30 degrees altitude of Polaris. So let's go over some of your questions in your worksheet. At a location in the northern hemisphere, a camera was placed outside at night with the lens pointing straight up. The shutter was left open for 4 hours, resulting in the star trails shown below. At which latitude were these star trails observed? So this is saying it's in the northern hemisphere, right? Camera was placed out in the night. So it looks like this would be the North Pole, 90-degree north, because Polaris is right here. Polaris is not moving, but the other stars look like they're moving around Polaris, right? Just like we were seeing. And this only looks like it looks like this in the North Pole, 90-degree north. Okay? Next one. What is the latitude of this observer? The diagram below shows an observer on Earth measuring the altitude of Polaris. So here's an observer. This is their horizon directly in front of them. This is the zenith directly above them. And here's Polaris. What is the latitude of this observer? The correct answer is B, because the latitude of the observer will be equal to the altitude of Polaris from the person's horizon directly in front of them. So here's the person's horizon. Polaris is 66.5 degrees above their horizon, and that will equal to their latitude. This person is at 66.5 degrees north of the equator because the Polaris is 66.5 degrees higher above their horizon. Okay? And that's about it.